So solving these inequalities without a calculator, we need to first establish the boundary line. Okay, so this is a two-variable inequality, so we need the line as a boundary, which means we need to be able to draw this graph. So we have to go back to our quadratics, and essentially this is really more of a graphing quadratics problem. So to graph this, I think I'm going to factor this. So I'm going to have x minus 3, x minus 2. Sorry, this is not true. It's going to be x minus 5 and x minus 1. So I have zeros at 1 and positive 5. I should establish my vertex. My vertex is going to be in the middle, so it's going to be at x equals 3. When I plug 3 in, I get negative, looks like negative 4. So at x equals 3, y equals negative 4. So when you're graphing these, I want you to make sure that you are able to draw this parabola. So for parabolas, we really need a vertex and two symmetrical points, and that's good enough. That's all I'm going to ask for you do. If you want, you can put in the Y-intercept here and do a symmetrical point, so that's easier to graph. This is not equal to, so where the boundary line is going to be dotted. And there's our boundary. And at this point, we just need to establish, are we above or below this boundary? So we can do it in two ways. We can use the y is greater than to establish that it's above the line. Again, let's not start talking about inside, outside. It's either above or below. I can test the coordinate. And the best coordinate to test is 0, 0. And when I test 0, 0, I get y is greater than 5. Sorry, 0 is greater than 5. That's not true. So we know that that point outside the below the boundary is not part of our solution region. So there it is. We solved this inequality without a calculator. This involves, again, we need to be able to draw our quadratic functions. So here, if I'm going to deal with this two-variable inequality, again, I need to first of all recognize it's two-variable, and my solution is going to be an area in the two-dimensional space. I'm going to rewrite this in terms of y equals. Okay, so I'm going to move the y. Oops, I don't need to do that. I'm going to keep the y on this side, and then I'm going to end up with negative 2x minus 3 squared plus 5. So by doing this, it allows me to draw my boundary region using my quadratic, what I know about quadratics. So my vertex is going to be at 3, positive 5. I know it's pointing down. I should use some symmetrical coordinates. So let's maybe I'm going to use the y-intercept. So I'm going to use x is 0. Plug in x is 0, I end up with, looks like negative 3 squared is 9, times negative 2 is negative 18, plus 5 is negative 13. Okay, so I'm going to go down to negative 13 somewhere around here, and then x is 6 is going to be the symmetrical point to that, so 3 over 3 to the left, 3 to the right. I'm going to end up with negative 13 here, so plugging that in, is negative 13 is about there. Okay, so 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, maybe just a little bit high, so maybe right about there. Okay, and so those represent my symmetrical points. I could also use the parabola of progression, so instead of with the expansion, so 1 over 2 down, 1 over 2 down, 2 over 4, so we're going to double that, so 1, 2, 3, 4, and then 8. Okay, so 2 over 8. Okay, so we could use that progression as well. Regardless, I want the vertex and 2 symmetrical points. Okay, here I've given 6 symmetrical points, so we don't necessarily need that many. But there's my boundary. It's a solid line because it's equal to that boundary. And then I have to establish above or below. Actually, I should probably put in a couple extra coordinates here. So I'm going to go negative or positive 2, positive 3, positive 4, positive 3. Okay. So I need to establish, am I above this boundary line or below? So y is less than, so that means it's below. So I need to shade this area here. Okay, so that's one way. We could also establish our boundary by testing. Okay, so again, these are alternative mutual methods that we can cross-reference. So we're going to test, again, my test point. The easiest coordinate to test in this space is 0, 0. So I get 0 is less than or equal to negative 2 times negative 3 squared plus 5. So 0 is less than or equal to, it looks like that's going to be negative 13. Yeah, that's our coordinate there. So in this case, 0 is not less than negative 13. That is wrong. That does not represent a point in my solution space. Okay, so that above the x-axis, above the graph, represents a non-solution because that point is above the graph.